I'm going to briefly describe how to use an Excel spreadsheet that calculates the Gibbs free energy as a function of temperature when the heat capacities and the heat reaction are both functions of temperature. So spreadsheet's located in the LearnChemE site, and let's look at the spreadsheet. The actual details of these calculations are explained in other spreadsheets, so I won't go through them here. So this spreadsheet is for 4 molecules are involved in the water-gas shift reaction, and so the values for A, B, C, and D, these constants are from a table, and then we calculate delta A, as explained in other spreadsheets. It's products times their stoichiometric coefficients minus reactants times their stoichiometric coefficient. And if I change this temperature, this is really the only user input, change this temperature, then it'll calculate the values of heats of reaction and delta G at different temperatures. So let's look at the right side of the spreadsheet. Here are the heat capacity at 298, just from tables. These constants J and I are defined in the table below and are explained in other screencasts. But you can see the equation, they're related to, in this case, the heat reaction at 298, and essentially turns from the integral evaluated at the reference temperature, which is 298. This other constant is similar for the delta G calculation. So here, delta G divided by RT, and again at 298, so just read from tables. And here's the calculated delta G because I have temperature 298. If I make this, say, 700 Kelvin, then of course delta G's are significantly different. Well, also listed here are delta H at the temperature, in this case 700. And you notice it changes slightly, doesn't change very much at all. For CO2, this is, of course, delta H of formation from the elements. And then the other thing that I've added to this spreadsheet, well, we also have the heat capacities of the elements because we need them to calculate delta G's of formation. And that's what we're interested in. These tables are delta G's and delta H's of formation. But these 4 components, these 4 molecules, CO2, CO, water, and hydrogen are involved in the water-gas shift reaction. So we can use the delta H, delta G's of formation to calculate delta H of reaction and see how, as I raise the temperature, delta H of reaction changes over, 700 degrees, changes significantly. Delta G for the reaction, of course, changes much more. So the spreadsheet allows you, of course, other molecules could be substituted with different heat capacity terms, and calculations could be done for other reactions. The heat capacity is listed here more as a check that if I put in 700, are these values reasonable values for the heat capacity?